Alright, so in today's video, we're going to look at magnetic declination in geography map work. And I promise you, by the end of this video, this topic is going to feel much less stressful. Before we start with any calculations, it's important to know which map we're working with. So in this lesson, we're going to work with Queenstown's topographic map. We can see clearly with the scale. That means that all the information we use and all the calculations we do apply specifically to the Queenstown area. Magnetic declination is always linked to a specific place. So if we use a different map, the values could be different. Now let's talk about what magnetic declination actually is. Magnetic declination is the angle between true north and magnetic north at a specific place on Earth. The reason magnetic declination changes over time is because the Earth's magnetic field slowly shifts, and the Earth itself is constantly moving. This means that the magnetic position of a place like Queenstown does not stay exactly the same every year. Because of this movement, the magnetic declination must be updated over time. That's why map makers give us two very important pieces of information: the mean magnetic declination, which is the position at a certain year, and the mean annual change, which tells us how much the magnetic position moves every year. Okay, now let's look at where on the map we actually find this information. If you look at the bottom margin of the Queenstown topographic map, usually below the scales, the line scale, you'll see a small diagram showing true north, magnetic north, and grid north. Okay, so here. Next to the diagram, the map gives us the mean magnetic declination, the mean annual change, and the year that the magnetic declination was measured. That year is extremely important because it tells us when the magnetic declination was correct. Okay, so this part. Okay. On the Queenstown map, the mean magnetic declination, is 28 degrees 25 minutes west. It was measured in 2017, so this map was from 2017. And the mean annual change is 10 minutes west. Okay. Now that we all have all our information, let's go through the steps. Okay. So let's start with step 1. Okay. Step 1 is to calculate the difference between the years. So for this step, we use the year printed on the map and the current year. Unless the exam question paper gives us a specific year, we never guess the year. We read it directly from the map. So it's 2025 because it's the current year. Always the current year unless they say otherwise. Minus 2017. And that will give you a total of difference, which is 8 years. Then let's move to step 2. Step 2 is to write down the mean annual change. So according to the map, the mean annual change is 10 minutes west per year. This tells us both the amount of change and the direction of change. So direction is also very important. Step 3 is where we calculate the total change over time. We multiply the difference in years by the mean annual change. So 8 years multiplied by 10 minutes gives us 80 minutes. west. Okay. This means that since 2017, the magnetic position of Queenstown has shifted by a total of 80 minutes west. Okay. Then, now we move to step 4. Step 4, we write down the original mean magnetic declination exactly as it was on the map. So the value was 28 degrees, 25 minutes west. Okay. This is our starting point before we start doing any sums. Now, number 3 and number 4 are important for our last steps. So now you're done with step 1 and step 2. In step 5, we calculate the current magnetic declination because the mean annual change is west. We know that the magnetic declination moves further to the west, which means we must add the total change to the original value. We always start by working with the minutes. So we take the original minutes and we take the original minutes, which was 25, and we add the 80 minutes we calculated in step 3. So we're just going to write this down. There's nothing that's going to change here. Not as yet. And then 25 minutes west. So now you're going to plus your 80 minutes west. And this gives us 105 minutes west. Now, an important rule you must remember, you're not allowed to have 60 minutes or more in your final magnetic declination answer. Just like in time, where 60 minutes is equals to 1 hour, in Mapwork, 60 minutes equals to 1 degree. So when we take 105, so take 105 and we convert it, 60 minutes becomes 1 full degree, and now we're left with 40. We are left with 45 minutes. We now take the extra 1 degree and we add it to the original 28 degrees. So 28 plus 1 is going to give you 29. But that is not your final answer because you must say west from to north. And that is your final answer. Before we end, here's an important exam tip you should always remember. If the mean annual changes west, you add. If the mean annual changes east, you subtract. If you follow these steps slowly, use the map correctly, and always convert your minutes properly, magnetic declination becomes one of the easiest marks in geography map work.